So this morning we're going to go ahead and take a look at some parabolas that are in quadratic form, they're quadratics, they're currently in product form. And this is the easiest form to find the roots. To find the roots, we would use the zero product property and set them each to 0 and solve. So here we'd have a root of 2 and a root of -8. Here we'd have a root of 3 and a root of 1. Here we have a root of -10 and 2.5. And here we have a single root, so that means it's the vertex at 7. However, what we're going to be doing in this product form today is we're going to work backwards. We are going to take a look at the product form, which we can get from the roots, and then we're going to go ahead and put it back into standard equation, which is y is equal to ax squared plus bx plus c. Okay, so the way we're going to do this is by using the outside of a generic rectangle. We also could use the double distributive property as well. So I'm going to do the first one using those outsides of our generic rectangle. So we put our first term underneath and our second term up the side. And then we're going to multiply, 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 multiply. X times x gives me x squared. X times -2 is -2x. 8 times x is 8x, and 8 times -2 is -16. Now we're going to finish up by combining like terms, and those are always going to be those two at that diagonal. And we have x squared, y is equal to x squared. 8x minus 2x is positive 6x minus 16. And that is our answer in standard form. And then we can go ahead and check it with our Desmos graphing calculator. We type in our problem in product form, and there is our parabola. Let's go ahead and get it so we can see the root as well. There we go. And then we type our answer. So our answer here was x squared plus 6x minus 16. And as you can see, they're the same parabola, and they have a root at -8 and a root at 2. So we know that we solved that correctly. Now, the other way that you can solve this is called double distribution. And so basically, you're going to ignore that -2, and you're going to multiply that x by each item in the other form. So x times x is x squared. X times 8 is positive 8x. We then go ahead and ignore that x, and we distribute that -2 to each item inside the other set of parentheses. So -2 times x is -2x, and -2 times 18 is -16. When you do this technique, the ones in the middle are going to be the ones that you combine. And once again, you're going to get the same answer. Y is equal to x squared. 8x minus 2x is positive 6x. And then we have minus 16. So these are two different techniques. The generic rectangle works really great because it's easy to see which ones you need to multiply together. This one is faster once you get that, then because you don't have to draw the outside of the generic rectangle, you can use the regular problem. So either technique, whichever one is consistently getting you that correct answer. Okay, let's go ahead and look at the next one. We have a 3x minus 9 and an x minus 1. 3x times x is 3x squared. X times -9 is -9x. 3x times -1 is -3x. And -1 times -9 is positive 9. We're going to combine like terms for our final answer. And we have y is equal to 3x squared. -3x minus 9x is -12x plus 9. Okay, and then we can go ahead and check those answers once again. We have a 3x minus 9 and an x minus 1. Okay, and then our answer was 3x squared minus 12x plus 9. And as you can see, we are correct. The reason we know we're correct is because those parabolas are right on top of each other. Okay, our third one, we have an x plus 10 and a 2x minus 5. 2x times x is 2x squared. 2x times 10 is 20x. X times negative 5 is negative 5x. And 10 times negative 5 is negative 50. Take a look and combine our like terms. And we have y is equal to 2x squared. 20x minus 5x is positive 15x minus 50. Okay. Now our last one here, like I said, when we see it in this format, it means that there's a single root, and that single root is going to be at the vertex. But we can rewrite this knowing that we have our base times itself, like 3 squared is 3 times 3, 5 squared is 5 times 5. We know that this is x minus 7 times x minus 7. So as we're setting up the outsides of our generic rectangle, we're going to put x minus 7 in both. And then we're going to multiply x squared. X times negative 7 is negative 7x. X times negative 7 is negative 7x. And negative 7 times negative 7 is positive 49. We're going to combine those. And our final answer is y is equal to x squared. Negative 7x minus 7x is negative 14x plus 49. And this is called a perfect square trinomial. There's 3 terms. We have a perfect square up front and a perfect square as a constant. Let's go ahead and look at that one because that one is a little bit different than the others. So we have our x minus 7 squared and then our answer was x squared minus 14x plus 49. And as you can see, once again, we did get it correct because they're the same parabola, and our x-intercept is the vertex as well.